Okay, so good morning, everyone. I will be discussing with you about how we solve this um, items using Cramer's rule, inverse rule, and Gaussian method. So yeah, let's start first with item number 35, which is 6.3 x plus 2.1 y is equal to 18.9. So the first thing we do is to do it in a matrix form. That's why we have 6.3, 2.1, 1.5, and 3.4. We just cross multiply this diagonally, and after cross multiplying, after getting the product, we just subtract their products and get the final answer. So in here we have 6.3 multiplied by 3.4, which is 21.42, and 2.1 multiplied by 1.5 is 3.15. After subtracting this one, we now get the answer, which is 18.27. So we need to find the x and y in this item. So the formula in getting the x and y is dx over d and dy over d. So we just first solve the dx. So in solving the dx, you just need to replace the x column with its constants, which is 18.9 and negative 4.2. So after changing this column, uh, let's just simply cross multiply these items diagonally, and after getting their product, we just need to subtract them. So the answer is 73.08. So again, the formula in getting the x is basically dx over t. That's why we need to divide the 73.03 in our d, which is 18.27. That's why we have here x is equal to 4. The same thing goes for dy. For dy, we just need to replace the y column with their constants, and after replacing this one, we just need to cross multiply this item, and after getting the product, we just need to subtract them. So the answer in this item is negative 54.81. We need to divide this in our d, which is 18.27, and our final answer for y is equal to negative 3. So the same process goes with item number 36. You just need to first find the d, and after getting the d, you just need to find the x and y using the formula. The same process, you just need to replace the x from its constant and y from its constant, and you just need to cross multiply this item and subtract them, and after subtracting them, you just need to divide with the answer, and yeah, you can get your final answer. So that is how we solve this item using the Cramer's rule. Next one is we will solve this item using the inverse method. So in solving this item using inverse method, the very step that we need to do is to first write them in its matrix form. That's why we have here A is equal to 6.3, 2.1, 1.5, 3.4. And for our X, we have X and Y. And for our B, we have here 18.9 and negative 4.2. So, after writing this item in its matrix form, we need to calculate the inverse of the matrix coefficient. Now, in writing the inverse of the matrix coefficient, we have here a negative 1, 1 over 18.27. So, in writing this one, instead of writing this matrix into A, B, C, D, we need to write it as D, negative B, negative C, A. That's why we have here 3.4, negative 2.1, negative 1.5, and 6.3. And after getting the, after calculating the inverse of A, we need to perform a matrix multiplication. Alright, that's why um, we will multiply these items into our constant matrix, which is 18.9 and negative 4.2. Again, you just need to multiply this using row by column, or row multiplied by column. So after performing the multiplication of matrix, we now have the answer, which is 73.08 and negative 54.81. You just need to multiply this into 1 over 18.27. After getting the product of these items, we now have our x and y, which is our x is equal to 4 and y is equal to negative 3. So that is how we solve this item using the inverse method. So that is how we solve this item using the inverse method. Next one, let's proceed to Gauss-Jordan method. Using the solving this item using Gauss-Jordan method. So in Gauss-Jordan method, our main goal here is to make the matrix into 1 0 0 1. We just need the 1 diagonally and 0. 0. So in getting this goal, we first need to make the 6.3 into 1. That's why for row 1, we need to divide row 1 by 6.3 itself, because 6.3 divided by 6.3 is equal to 1. So after that, we now have 1, 0.0033, and 18.9 divided by 6.3 is 3. So the next step that we need to do is to focus on row 2. We need 1.05 to become a 0. That's why in becoming this, we need to minus row 2 minus 1.5. So now we have here 0, 2.9 and negative 8.7. So since we all have this 1 0, we move to the next column. We will focus on this 1 over we will focus on this 2.9. So we need to transform 2.9 into 1 because that is our goal. That's why what we need to do here is to divide the row 2 into 2.9. So after dividing the row 2 into 2.9, we have here 0, 1 and negative 3. So the last thing that we need to do here is to make the 1 over 3 make into 0. That's why we need to deduct row 1 by 1 over 3 and multiplied by row 2. Okay? So in performing this item, using the PEMDAS rule, we need to multiply first before subtracting. Okay? So we need to multiply negative 1 over 3 by row 2, and after getting its product, we need to minus this into our row 1. That's why we come up with 1 0 0 1. So our x and y is our constant that is found in the very last side, which is 4 and negative 3. So our x now is equal to 4 and our y is equal to 3. So that is how we solve this item using Gauss-Jordan method. Remember that our goal here is to make this into 1 0 0 1 if we have 2 by 2, and if we have 3 by 3, we just need to make the diagonal part 1 and other numbers will need to become a 0. So yeah, in performing Gauss-Jordan method, we can basically subtract, swap rows, and multiply this into a number by a non-zero. So yeah, that is how we perform this. That is how we solve these equations using the Cramer's rule, the inverse method, and of course the Gauss-Jordan method. So thank you and God bless.